The next session is very exciting. Our vice president for the Internet of Things, and before I knew Dirk, I didn't fully understand and appreciate the effect that the Internet of Things was going to have on public sector. So I'm going to turn it over to Dirk right now. Appreciate all of you guys paying attention the rest of the afternoon, and excited to hear what Dirk has to say today. So thank you.
So good afternoon. Can you hear me? Yeah, and I know it's a very bad hour after lunch and getting dark outside, so I hope I can give a little bit of energy back. And who of you has seen Andy Jassy's what we call fireplace? Hands up. So then you all know that now I feel a little bit embarrassed because apparently I have to change my title from Vice President IoT to Vice President Buzzword, because apparently that's what IoT is. And I thought, okay, what better way than to start to try to make sense of IoT and give it a definition? Because if there's so much buzz, what is the buzz about and what do we talk about? And I thought, okay, what is the Internet of Things? And as you can see, I emphasize the plurality of things, and I do so for two reasons. The first reason is the analysts and the press. I hope there is no analyst or press in the room, and if yes, then please come afterwards and I will apologize. Because what you typically see when analysts and press talk about the things and the Internet of Things, it's this type of chart. It speaks about billions and billions and billions of numbers about things that we will have going to the future. It's always the timeline and always numbers which grow exponentially. And it started with the Gartner hype cycle something like a few years ago when we were talking about 20 billion things. In 2020, then I read 75 billion things. And I think I even found some prediction of 200 billion connected things within the next 20 years, so it's amazing. So apparently, it's about a lot of things, so a very big S after things. And the second part why I wanted to emphasize the plurality of things is that still today, when we talk about IoT, a lot of effort is about connecting and managing and writing application for one single thing. So think about Amazon. If we had written an application which would manage and steer one single of those robots, imagine what problems we will have in our fulfillment centers. Because in reality, we have more than hundreds of thousands of these Amazon Robotics developed robots in our fulfillment centers all over the world, and they have to work in concert with each other and our commerce platform that they deliver our goods safely, reliably, and very quickly. Sometimes as quick as just 1 hour when you hear about Amazon now. So one thing to remember, we talk about a lot of things, and it's about how these things do actually act in consultation. And of course, the other thing is, if you want to know about a definition of something, very easy is you simply look it up. And where is the world of wisdom today? In the Wikipedia, of course. And that was saying is, what does Wikipedia say about the definition of IoT? And I try to put some nice little pictures. So if I remember correctly, Wikipedia says that the Internet of Things denotes a network of physical objects embedding electronics, software, sensors, and connectivity, which enables those physical objects to collect and share data. So yeah, physically, that's correct. But I would like to give it a little bit a different perspective. I guess when you would ask somebody today about the former buzzword, which was called Internet, and you would ask somebody, what is the Internet? I bet that the vast majority of you will hear back the Wikipedia explanation that the Internet is actually a global system of interconnected computer networks which uses the Internet Protocol Suite, abbreviated TCP/IP. I guess most people will answer about, oh, the Internet, there's great applications, fantastic services, and it's the information resources which we can access through it. So it's much more about the value. And I thought I'll try the very same thing here. What if we were to take a value approach to IoT? And the moment I personally got very much excited about IoT was when a wise man asked me a question, which I put down here on the slide. He said, imagine you knew the state of everything in the world. And what if you could store this knowledge about everything in the world and get all the other knowledge as well, and you had infinite compute at your fingertips? Which problems would you solve? And at first I thought it's a trick question before I said, no, I mean this really serious. And then when I started thinking about what problems would I solve, I realized, wow, there's actually enormous potential impact that the IoT might, or most likely will have, on human beings in our lives. And what I will do now is show you some answers to that very same question from different companies in different areas. And let's start with the healthcare domain. I'm a son of a medical doctor, and my own son has in reality a disease, a chronic disease, which we never figured out what is really the cause. And having experienced this myself, I realized in saying is it's almost unbelievable how anachronistic our healthcare system still works today. If somebody has a serious condition and you go to a provider or a doctor, the diagnosis about what is actually wrong with you, and more important even than the type of treatment, what they recommend to you, is most likely to almost 100% depending on the wisdom and the knowledge of the doctor, she or he sitting in front of you and what is their experience. But what if similar conditions have been recorded somewhere else in the world, hundreds, thousands, or even 100,000 or million times in India, in China, in Sri Lanka, in Russia? What if you could apply something like automatic pattern recognition in MRI or ecological pictures? What if you could use machine learning to classify the different symptoms? What if you could analytics and predictive analytics to predict the probability of a certain treatment? What impact would that mean into our healthcare system? And a company like Philips, who started out, specifically Philips Healthcare, selling medical equipment, is on exactly that very same journey to revolutionize our healthcare system. And they're not alone. So, and you heard Andy, so tons of data they ingest into our back end, a lot of analytics there, and they even can improve the machinery which is out in the field, because when you learn something about how this machine act and work, you can adapt some of the algorithmics back to the machines as well. So you can even improve existing machinery outside in the field. Or take a complete different topic. Take agriculture. And I didn't put a name because we in reality work with several companies. Is it big farm equipment manufacturers or some of the biggest companies in the world who actually produce fertilizers or seeds? And they said, wait a minute, if we knew at any given point in time when we want to plant a seed, the chemical and physical decomposition of the soil, and if we knew exactly what type of seed, at which size and where it comes from, with all the empirical knowledge that we collected, we know exactly at what depth we should have to plant the seed, how much additional fertilization it needs, and what irrigation. And by doing so, there is a big promise of increasing crop yields, not only using the same amount of resources, but actually using less resources. And what you see here, helping farmers to take action, plant more efficiently, and improve crop yield, it's reality already today. And it's made real by this IoT, the Internet of Things. And there are more examples. Another is Rakio. I mean, it's a little bit more in the almost consumer space. It's a company who came out with an intelligent sprinkler systems for landscaping. And of course, they started the system, said, okay, if I know about the weather, and I know about the slopes, and I know about how much water is actually absorbed in the soil, they put an intelligent systems and running on AWS. And according to them, the moment they started switching this intelligent system on, they alone were able to save more than 400 million gallons of water. Or is anybody from the Department of State in the room? If not, you might have heard that 2 or 3 days ago, I think there was a big announcement. The Department of State actually gave a contract to a company called C3 IoT, which is working very closely with AWS. The entire solution is working on AWS for energy management and analytics in order to achieve and maintain the sustainability targets worldwide. And in order to do so, they have to ingest and look at sensors at more than 22,000 department facilities in more than 180 countries in the world. So coming back to the question, for me, the value of IoT is actually the potpourri and the entirety of answers you give to that question, which problem would you solve? Individually, as companies, as public sector, or as countries. However, there's also a few conditions in that question, which is not trivial. And in order to understand how one can meet those conditions, knowing the state of everything and infinite compute and storage, let's look at the 3 constituents of IoT. And let's start again with the T. So we started with the things. Let's start here with the things. So let's start with the T of IoT, means the things that sense and act. You say, what's the big deal? Why do we talk now about IoT? I could have connected a chair 10 years ago. Yeah, that's true. What did it cost 10 years ago to connect a chair? Something like $5,000. So the thing that changed in the meantime was that the mobile revolution took place, and the entire value creation, which was driven by the PC industry, went to mobile. And now we have something what we call system on chips, which is in reality, in one tiny little chip, you have compute, memory, analog technology like sensing, and even communication and RF, which makes it now very affordable, even in the sub-dollar range, and therefore economically viable and meaningful to connect literally everything in the world. And then let's look at the I of IoT. And again, we talked about the internet. It's more about the value, about the application and the services. And what is powering the application and the services? It's not the TCP/IP protocol, it's the cloud. And it's the cloud which we have seen growing over the last 10 years. And you could argue, okay, as a company, one could have built up a data center, but it just took months, sometimes years, and a lot of money. But today, and also as you have heard our CEO talking about it, literally today, every single individual with a credit card can spin up almost infinitesimal amount of compute in storage by going to a public cloud provider like AWS. And that's the one place where now all of this data that this gazillion and billions of devices collect, you can put into, you could store, and you can compute on top of this. And in that sense, if you like, IoT took up and started accelerating with the advent of the cloud and with the availability of these tiny little chips, which are called SoC. So if I like to say it because it makes more sense to me, IoT is actually really born when the internet met the cloud revolution. But there's one more letter in the acronym IoT, which is a very overlooked letter, which is the tiny little O. And I'll try to repurpose it. And I use the O for orchestration because the key question is, what do I do with all of this data? And what I do with all of this compute? And here's the trick saying is, if I can now apply domain knowledge, like in the farming, or in the medical industry, or even in energy, and then I can use the mechanisms that we have in the cloud and the services to do insights generation on top of the data, I can apply the business logic on top of things, which then in reality go back to the cloud and to the things and generate action. So that I come to very complex but intelligent system. And it's that what we call the intelligence layer. It's that layer where you get the most value out of IoT. And in that sense, looking at these three constituents, I actually like the acronym IoT. So IoT, the only thing I would do is I would really use the letters differently. I would use the I for intelligence. I would use the chop, the O in the middle, so that it says C and O. So that comes to cloud orchestration, and T is for things in plural. So intelligence, cloud orchestration, and things in plural. That is the constituents of IoT. And when you look at the IoT taxonomy, where you have these gazillion of things communicating to each other, or devices communicating to the cloud, data ingestion to the cloud and cloud connectivity, you need to do insights generation, you need to do business logic application, you make sure that it goes back to the things, and you have to make it somehow visible to the human beings. It's obvious that we talk about very, very complex end-to-end solution. But again, coming back, what we really want to do is we would like to answer the questions, how do I solve my problems or business problems? The reality, however, is that most companies, when they start, struggle with very basic questions. How do I connect my things to the cloud? How do I connect billions of things to the cloud? How can I manage my things? How can I update them? How do I visualize the data coming from my things? How do I reason on top of it? How do I generate the insights? How can I apply my business logic? And how can I actually write applications and build these great solutions on top? And that's where AWS comes into play again. And that is what we took as our starting point in saying is, wouldn't it make sense if we as AWS, with our experience in the cloud, would come up the underlying plumbing, answering all of these wide questions that you would not have to worry about this complexity, but you can put most of your resources and intelligence in answering the real question, which is important to you. And that was the birth of AWS IoT, which is secure, serverless managed service. And don't be taken aback about the complexity of the diagram, what I put down here. So I just wanted to give you a few data points, why we built the service and the solution as it stands here. You remember I was talking about things, about the plurality of things. So the first question, how do I connect 1 or 1 billion things securely to the cloud? That's what we tried to answer first. And we went for a serverless managed service. So, and you have heard beforehand some of the people on the panel saying is, when you go into this serverless managed service architecture, you don't have to worry about capacity. You don't have to predict whether you have one thing, a billion, or 300,000. So we give you the means to just connect your things securely, and whether you have 1, 100,000, or 1 billion, AWS takes care of the rest. On top, secure is an extremely important word in our secure serverless managed service. Because, of course, you have seen some of the application and solution in the healthcare space, very personal. We want to make sure that we do the right thing from a prevention instead of afterwards going and trying to cure something that happens to our system. So, and what we then decided for is that we need mutual authentication, authorization, and encryption for everything connecting to our cloud. And what does it mean? I mean, most of you most likely have ever used, I guess, Amazon.com or a similar e-commerce site. And why can you use this securely? Because there is something which is called a certificate, which is sent from the server side to your browser, which you can trust, which you know, okay, it is really the real service which I'm connecting to, and then, of course, you need to log in. And we do a similar thing in the IoT space, plus we also require the things to have the same certification towards the service. So you can, like, it's double secure. It's not only the server side which needs to authenticate itself via secure certificates, the same is on the things space. So very important for us. We will not compromise this. And on top of that, then, of course, a lot of these tiny little devices, they simply don't speak the language of the internet. So the TCP, IP, HTTP, and HTTPS protocols. So we needed to find a way in saying is how can we have much more compute-constrained devices, also battery-constrained devices, to more or less talk to the cloud. That is the first questions we answered with AWS IoT. The second set of questions was, okay, now I connected all of this to my service. How do I make sense of the data? And that's what you see in the middle, which says the device gateway and rules engine. This is more or less all the messages come in, and you can look at the messages, and depending what is in the message, where the message comes from, what time of day it is, certain action is given. You might just decide that some data is put into a data warehouse, or it's stored. Or you'd put additional rules saying, okay, there comes temperature is too high in a certain process. Open a valve to release the pressure. Or you figure out, I want to do something else. I want to apply certain business logic. Then we invoke something what we call the Lambda function. I mean, you have heard Andy discussing beforehand what is the next step of more or less serverless compute from the container ECS structure. It is Lambda of the serverless compute, which more or less is a very, very cost-efficient and very, very versatile way for you to apply your business logic. That's, by the way, the same service which is underneath our Amazon Echo and Alexa service. So whenever there's a new skill and something works with Alexa, it's using Lambda. It's the exact same technology in order to do so. And then, of course, if you want to visualize things or you want to do stream analytics, we pass it to Kinesis. You can put it in Redshift. You have QuickSight for business intelligence. So it's literally the gate to the full service spectrum and building blocks that AWS has to offer. And last but not least, it addresses the question of how do I write now my application? What do I need to do as a developer? And you can see all we do here is, again, API-driven, REST API-driven. And when you talk about the Thngs space, then we call about SDKs. We mean software development toolkits. That is software that you can install on your devices. So you don't have to invent that software. We offer that for the different operating system and also in native code. So to cut a long story short, the complexity of the underlying plumbing, we believe we have solutions and services in a secure and managed way for you so that you can really start thinking about the core questions, which is solving your business problems. So I just summarized all of this as the AWS IoT characteristic, and of course there's a ton of material. And since I only had 20 minutes, and my time is already up, I thought, okay, there was a lot of information in a very short time frame. So how would I summarize this? And I think there's always good that if you have 3 things to remember. And for me, my 3 things to remember is, when we talk about IoT, forget about the bus. For me, IoT is really significant because it's the collective answers to which problems would you solve question. That's the power and the promise of IoT. Secondly, what is IoT from a technical perspective? Remember, I, intelligence, O, CO, cloud orchestration, and T for things and plurality. And last but not least, don't be afraid and take yourself off from the pretty complex, distributed compute nature of these intelligent systems. There are ways from AWS, and of course there's also other cloud providers who do this, to come and do the plumbing for you that you finally really take care of what you're really after, answering the first question. With this, I hope I brought you IoT a little bit closer to your heart as it is to mine. Take a little bit away the bus and bring it down to reality. Thank you very much.